Afternoon, learners and teachers. This is a great day's presentation based on algebraic expressions, which is a continuation of a previous presentation. So we look for the algebraic expressions, what we'll be able to get at the end. Expand and simplify algebraic expressions. Use commutative law, associative law, derivative law for rational numbers and laws of exponents to multiply integer with monomials, multiply integer with binomials, multiply integer with trinomials. Then from there, we also multiply the monomials with the monomials, multiply the monomials with the binomials. Also, we multiply the monomials with the trinomials. So these are our learning outcomes that we need to expect at the end of these lessons. So as we discussed previous lessons, we're going to also embark also same thing scenario of using algebraic tiles and also incorporate our traditional way of teaching. So remember, last time we said that develop your own tiles using n materials, where each bigger tile is the x squared tile, 6 by 6, the rectangular shape for x, 6 by 1 units, and the smaller square, 1 by 1. So this is what we have as our results. Remember, the blue represent the positive, red represent the negative tiles. So this is called about areas. The first area is x squared, x by x. Second area is x times 1, gives us x. So remember, just highlighting what we left. This is our x squared, which is positive, x squared units. That is our x times 1 unit, give us x unit. Then we have also 1 by 1, give us 1 unit square. Then for the negative tile, we have x times x, give us negative x squared units. And we have 1 times x, give us x units squared. Then from there we have the last tile, which is minus 1 unit squared. Remember the properties that is very important. Any two equal tiles with different colors cancel out when you add them together. Example, we have x squared and minus x squared, give us 0 as a 0 principle. Then we have also another tile which is negative x times negative x, give us also 0 and a square unit tile. So now let's go to our topic, which is called the multiplication of algebraic expressions. So now when we look at this, so take this one as what? Integer and a monomial. So in this case, treat 3 as a side of the rectangle and treat 2x as also side of the rectangle. So we're interested here how much the area we're gonna able to get. So now when we look at the side, we're gonna place our square units. How many square units we're gonna have here is 1, 2, 3. And this side we're gonna place our rectangles, which will be also how much x and x. This is how we place it. So then now we want to find out how much the area must have here. So remember, we want to develop the concept of what? Multiplication of the integer and the monomials. But now we use what? The algebraic tiles. Now when we look at this unit square together with this x, so what happens? We're going to be able to, when we combine the two, we must place what? The rectangular tile. Or this one again, towards this one, also place what? The rectangular tile. So we cannot place what? The 1 square unit and 1 square unit here. Because we must fit exactly our area here. This is how we have. So now let's look at this. How many tiles are here? It's 1, 2, 3, 4, 5, 6. So it means that our results at the end are going to be how many tiles? 6 tiles. So we talk about what? 3 times 2x give us 6x. So it means we look for the issue of tiles to be how much? 6 tiles. These are rectangles. So it means how much? 6x. So this is what we have. This side also we have what? Minus 2 times 3x. So this one, how many we have? Red means what? Negative. 1 unit, 1 unit. Then 3x, 1, 2, 3. Then how much our area inside here? Why is negative? Because the color is negative times different color, which is blue, give us negative. So if the tiles are not the same colors, we take what? The color which is negative in this case. So let's continue. Integer by the monomials. Same again here. So they have these results. So we have 6x. We have arrived to the solutions. So we have 1, 2, 3, 4, 5, 6 tiles that we discussed. On the side again, we have, of course, we have negative. So we have how much? Negative 6x. 1, 2, 3, 4, 5, 6 tiles. So the next, now we want to multiply again the integer by a polynomial. Our polynomial is 3x plus 5. So let's see how much area we obtained here. So we place our rectangle. How many square units? 1, 2, which is 1 unit. Then now outside here on top, we must place how many rectangles? 1, 2, 3. And then also have how many? This 1 square units will be 5. So this is how we have. Then now, the area must cover here. On top, we have a square unit and a rectangular shape. So we cannot have what? A square and a square because it won't fit. So we must fit this area completely. So to fit this area completely, we're going to have what? Blue color and blue color will give us same results of a color which is blue. But now here we have x, we have the 1 unit and also what? And the x unit. To give us what? The x unit. This is what we have. And also again followed by the x units. And then from there now we multiply unit by unit. It gives us that. So this is how we have our results and product of that. So now if we look at this one now, we have this square, 1 unit square, and this x give us this x unit. Then this one again and this one again give us the x squared units. So these are the algebraic tiles. So now let's see how much our result we obtain on this regards. So now when we remove these ones, let's count now. How many? The x. 1, 2, 3, 4, 5, 6. So it means that we have 6 of this x units square tile, which is how much? 6x. So let's see how many square units we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is our results we have. So we have 6x plus 10. So the next one now we have negative 2 times 3x minus 5. Still use what? Algebraic tiles. So remember negative, you expect the red color for our tiles. So let's place it negative and negative. On top, we're going to put what? 3x plus minus 5. In terms of tiles, you put what? A blue, which is a rectangular shape, form 3 of them. And then again, this negative 5 represent what? The red tiles, 1 square units, with 5 of them. Now, when we multiply our results, so inside here, to get this area, we must cover this area. Remember, this one is red and blue, which is negative and positive. Remember, red dominates more a color. So we'll have much here now. It will be a red tile, which is the x units. Then followed by also the red, and the red, the red, and the red. Then now, be careful now. When we go to this one now, it's red square units with also the what? The red square units. Same colors. So because it's red and red, what we obtain at the end give us the positive ones, which is blue colors. So S means that if we have negative and negative, so the results go back to become blue, which is positive results. Then now, how much we obtain on this regard? So when we remove these ones, let's see, let's count 1, 2, 3, 4, 5, 6. We have 6 red tiles. So give us a negative 6x. How many blue we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 blue tiles, which is plus 10. So our result is minus 6x plus 10. Now we go for the next presentations, which is a monomial by a binomial. So x here is mono, but x plus 2, because there are 2 terms here, we refer as a binomial if you remove a bracket. Now let's see how we place our tile. Remember, this side will be x tiles, this side also will be x plus 2 tiles. So let's see. So we have placed our x in place. So now y is the square block. So to fit here, remember here we have a rectangle and a rectangle. Combination of it give us what? If you can cut this way halfway, you can see the rectangle and rectangle give us the square on it, because the rectangle here and rectangle combined, both of them can give us the square circular form, which is square box. So now let's see this rectangle. How much I must fit here now? Also must fit it here again to follow what? The area of this. So we have the rectangle and the rectangle. So let's go to the next one. We have x. Place it. Now, because of this minus 2 is negative, we're going to place negative values there. Then now when we multiply, we have the square box multiply with the negative ones. We're going to have negative and the negative. So what's our results? At the end, we have x squared and the x and x. So we're going to have x squared plus 2x. So this other side, we have x squared minus 2x as our results at the end. So let's continue again now. We have a binomial times by a binomial. So we have x plus 2 multiplied by x plus 3. So let's fit our area to see. Remember now we have x plus 2. We have a rectangle and also the 1 unit this side. So let's place it. Let's make how we put it. Rectangle, this 2 will be 1, 2. This side is x will be 1, 2, 3. So the results, when we multiply it again, we must fit what? The square box. This square box, this is a rectangle and a rectangle. Give us what? The x squared. So now we continue the rectangle and the rectangle and the rectangle. So we're going to have a rectangle and we also have a rectangle and a rectangle and a rectangle. So now this side again we have x, and x give us the rectangle. Then now we have the unit and unit. We have also the unit. So now go to the next one. What we have, these results, this is what we have. Now let's look at this one. How many squares here is x squared? How many rectangles we have? 1, 2, 3, 4, 5. So give us what? 5x plus 1, 2, 3, 4, 5, 6 plus 6 units. So we have x squared plus 5x plus 6. Now we have x minus 2 by x plus 3 using algebraic types. Write algebraic expression for the product. So same results will be applied here. So we have x minus 2 by x plus 3. So this also on the other side we have x plus 3. So we have x, and how many units? 3 units. So we can have this rectangle, and this rectangle give us what? The square, x squared. So let's multiply this one and this one again. How much we must fit again here? Because now this is red. So means that the color will be changed. Our rectangle become what? A red rectangle. Also again, because red also have what? A red rectangles. Then now also the blue and the 1 unit. We have red and a red, blue, red, red, blue, red, and red. So now, when we look at this one, this rectangle and this rectangle give us what? A square rectangle. So now let's see our results. How much we obtain at the end. So this means what? X squared. How many of the blue rectangle? 1, 2, 3. How many red? 1, 2. So now when we add this red and this red, we go back to what? Properties of zero laws. So we have x squared plus x. So how many red? 1, 2, 3, 4, 5, 6. We have 6 red, which is minus 6. So let's continue. So this is what we have as our results. X squared plus x minus 6x. So now we have x plus 3 plus x plus 3. So this can be written as x plus 3 all squared. So we place it both side x plus 3, x plus 3. So what we obtain here, we have this rectangle and this rectangle give us what? X squared. Then we have also the rectangle and the rectangle give us what? The rectangle and the units give us the rectangle. So when we continue again, we're going to have rectangle and rectangles. So means we must cover this area such a way that all the tiles are fitted on this area. Then now we must see how much will be left on this regard. So we have, let's see, we have the x squared. How many blue one? 1, 2, 3, 4, 5, 6. So we have x squared plus 6x. How many units do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 units. So our result here will be how much? X squared plus 6x plus 9. So this is our result we have. So let's look at now this one, x plus 1 by x minus 1. So if you look at this one now, different signs, the result, let's see how much we obtain. We have x plus 1 and x minus 1. Why red color? Because of this minus 1. So when we multiply again, let's fit it here. So when we fit this rectangle and rectangle give us what? The x squared, the box. Why blue? Because it's positive and positive here. So now let's see again, we have this unit, which is a rectangle x value and 1 unit square. So give us what? The rectangle. So now we have also the negative 1 unit squared and with what? The x unit squared. So give us the red. So lastly we have negative and negative. Negative and positive units give us negative. So now what much our results at the end we obtain? Look at this inside here. This means what is x squared. We have this, which is the positive x unit squared, and also this negative x unit squared. When you check the two, it gives us the zero principal law, which is this, and it gives us what? 0. So we are left with this one, x squared and minus 1. This is what we have as our end result. So now x squared minus 1. So x squared minus 1. Now the plain knowledge that we can do quick by inspection, we now add 5 into 3 plus 4. Remember properties of that. Number 2, we have 5 times 3 plus 5 times 4. You can just take a few seconds to work it out yourself and see how much the result will obtain. Then now from there now, after working out this one, what do you notice about the answers for A, B, C, D, E, and F? So now when we say 5 into 3 plus 4. You cannot say 5 times 3. This one is property says what? 3 plus 4 first and multiply by 5. So, but now, the result to obtain is this one. First one is 5 into 3 plus 4 give us 5 times 7 equals 35. Number 2 gives also 35. Then number means that A and B give us the same results. Doesn't matter which angle you approach. Start with the bracket first or multiply it direct. Then number C, we have the result again give us what? 28. Means the same result again. Number E and F is the same results. So in conclusion, we notice that number A and B is same results, and number C and D same results, and also number E and F give us the same results. So we can apply properties of what? Associative law, descriptive law, and the commutative law. We can apply that. Now, let's look for descriptive law. So look for descriptive law. See here, to calculate 5 times 34, one can break down this as what? 34 into 3 plus 4 and multiply each number by 5. So what do we have? 5, same as 30 plus 4. Give us 5 times 30 plus 5 times 4. We say that 5 distribute over the additions. This is also applicable to the expressions. So now we have 3 into x plus 7, which is give us 3 times x give us 3x. 3 times 7 give us 21. Multiplication distribute over additions. This is our property we can apply. So this one again is 3 times x give us 3x. 3 times 7 give us minus 21. This refers as what? Multiplication distributes over subtractions. So be careful now. This is wrong. 3 into x minus 7 give us what? 3 times x minus 3 times minus 7. This is wrong approach. But now the correct approach must be minus 3 times x minus 3 times minus 7 give us positive results. This is what we have. So those are errors the learners usually commit. Now use the descriptive law to apply this. We have 2 times 3x. Number 2, now we're going now to the traditional way of working out the algebraic expressions to see how much the result. Remember, this was the same thing we discussed. So if you look at our tiles here, will be 2 here, which is the 1 unit square, and also 3x. So how many rectangles? 3 rectangles. But now we use what? The traditional way of working it out now to see the results. We have 2 times 3x. Here is how much? Minus 3 into x plus 7. 2 times x squared plus x minus 7. So we'll be distributing each result over the brackets. So what we have, this is what we have. We have 2 times 3x give us 6x. Minus 3 plus 7 give us minus 3x minus 21. 2 into x squared plus x minus 1 give us 2x squared plus 2x minus 2. Then minus 3x squared plus 2x minus 3. One side of a bracket is this one, which gives us minus 3x squared minus 6x plus 9. Other side, 3 times x squared plus 4x give us 3x squared plus 12x. When we add the like terms, 3x squared minus 3x squared give us 0. So remember in terms of tiles, minus 3x squared and 3x squared. If you look at this one is negative and also this one is positive. We have red and then blue tiles. Remember, give us a 0 property law. So in this case, minus 6x plus 12x, this will give us 6x and then plus 9. So here we have minus 2 into x cubed minus 2x squared minus 4x plus 5. So we distribute. So we have minus 2x cubed plus 4x squared plus 8x minus 10. So here we say a squared b. So remember now we have a squared times a cubed. Laws of exponents also come to existing. Remember, say also root what? Laws of exponents. So if bases are the same, we add the exponents. That's why we have what? A squared of 5. So b remain the same. So we have also a squared times b give us minus 4 4b plus a cubed b b plus a squared b. So number g, we have x squared into x squared minus 3x plus 4. Other side is minus x into x cubed plus 4x squared plus 2x plus 3. So distribution of this one will be x times x give us exponent of 4. Why? Base are the same at the exponents. X squared times 3x give us minus 3x cubed. X squared times 4 give us 4x squared. So this negative now will be negative x times x cubed going to give us negative exponent of 4. Negative x times 4x squared give us negative 4x cubed. Negative x times 2x give us negative 2x squared. Then minus x times 3 give us minus 3x. We'll add the like terms and get the results. Now, other method we can use, we refer as what? A FOIL method, where we say multiply the first term. If we have x plus 1, x plus 3, so we must first multiply the first term, which is x times x. Then if we go for outer, so give us x times 3, and from there go for inner, 1 times x give us x. Then if we go for the last term, which is 1 times 3. So in this case, this one we multiply the outer x times 3, multiply the inner 2 times x. Then from there, look at this one, with 2 times to give us 6. So in this case, we have what? This case we have what? I think it must be minor mistake here. So pardon for me that. So let's go to this one. Start the following example and then expand the expression that follow. We have x plus 3, x plus 4. So let's use our FOIL method. If you look at our FOIL method, we're going to have what? X times x give us x squared. X times 4 give us 4x. X times 3 times x give us 3x. Then last term will be 3 times 4 give us 12. So if you notice this side, say to simplify x minus y, 3x minus y. You can skip 3 minus x. This other method again we can apply, which gives us x squared minus 3xy minus xy plus 3y squared. And from there, add the like terms. So this also can apply what? As a FOIL method. So let's look at the results. This one we have as our results. A minus b give us a squared minus 2ab plus b squared. Ax plus b. Remember, laws of exponents, a times a give us a squared, x times x give us x squared. Ax times the middle term give us axb, also axb, then for b times b give us b squared. So when we like terms give us 2axb. Then k squared plus m, k squared plus 2m. So k squared times k squared give us k squared of 4. Then k times 2m give us 2k squared m. Then m times k squared give us m squared, m k squared. Like terms give us 3k squared m. Then m times 2m give us 2m squared. So now 3x plus 2y, 3x plus 2y. So let's see it. 3x times 3x give us 9x squared. 3x times 2y give us 6xy. Then also again 2y times give us also 6xy. Lastly, we have 2y times 2y give us 4y squared. Remember the like. You can also add the like terms. In this case now we have two brackets, 4x plus 3, 6x plus 4. So 4x times 6x, 3 times 4. So this other side we have what? 3x plus 2, 8x plus 5. This is what we have as the result at the end. Then now, question says now, the expression in 4 above, C, D, E, and G are the squares of a binomials, where a minus b and a minus b is equals to a minus b squared. This is the same thing. So what conclusion can you make about the terms of a product where squaring a binomials? So in this case, the results, we just square the first term, which is a squared, and from there to get the result again, you double the middle terms, we say a times b, double it, but we keep the sign of the originals. Then you square the last term with its negative signs. So in this case, we have 3x plus 2y squared. So we're going to have 3x squared plus twice the product of 3x to y. So give us 3 times 2 give us 6xy times the product of that, which give us 12xy. Then you square the last bracket, which give us 4y squared. So this is how you can come to a conclusion on that when we square the binomials. So just to have the few examples A and B, C you can do it as examples. So we have 3x plus 2y all squared, which give us 3x squared twice 3x plus 2y give us 2xy. Then you square the sign positive 2y, which give us 4y squared. So we can work it out by inspection. So this kind again we have 2x minus 5r all squared. So we must square 2x, give us 4x squared. Then twice the product of 2 times 5r give us 2 times 5 give us 10 times 2 give us negative 20xr. We keep the sign of the original. Then now you square minus 5r give us 25r squared. Thank you very much for listening to me. That's the end of our lesson for 3 days.